Well, so sometimes you cover topics again in more detail, and that's what we're going to do. At least for today,
Okay.
I'll give you more information about it. This is approximately where I think you might be in this class. That's why I'm bringing it up. Okay. A and B are the legs, though. That's what's very important, and the
Yeah.
legs are smaller than the hypotenuse.
Okay.
Okay, so look at an example problem here, and just getting a little more room on the screen. There we go. All right. So let's say, give you a right triangle here, and I tell you that this is 6 and this is 8. A squared plus B squared equals C squared. What is the value of A and B? Or what are the values of A and B?
So A is going to be 36. We know. Yeah.
Well, A is 6, but when you square it, it becomes 36.
Yeah.
Okay, so you got to be careful there. It's not that this is A squared, it's A. What is the value of just B?
Okay.
Just B.
8.
Squared. Okay.
64.
Okay. Very good. What is the value of C?
10.
10. Now, why isn't it negative 10?
Because when you multiply, well, it could be actually.
Okay. Think about physically, though, what we're representing.
Oh, length.
A length. Yeah. Like if you went and bought a ladder, if you went to Home Depot today and got a ladder, it doesn't say you can get the one that's 10 feet long or negative 10 feet long. Your choice.
Yeah.
That would be silly. Okay. So the hypotenuse is always a positive number. Okay. So new problem here for you to try. Let me give you something different. Just increase
So
the
it's
difficulty.
gonna be positive.
It's always positive. Yeah. Okay. So again, A squared plus B squared equals C squared. I'd like you to solve this for letter B for me, please.
So it would be 5 squared, which would be A, would equal 25. And then 13 times 13 would equal 136. And then I take that 130 and then be 169. And then I minus 25 from there, 144, 144, what's it, cube? And that would leave me to 12.
B is 12. Very good. How would you describe the difficulty of that question for yourself?
It wasn't too difficult. You just kind of had to just do the right equations.
Got it. Got it. Okay. Yeah. So far, what I've been giving you are what are called Pythagorean triples. Have you heard that before?
No, I haven't.
So Pythagorean triples are ones that work out nicely. The A, B, and C are all nice numbers. And there's actually an infinite list of these. But we're going to move past that because clearly you understand this. So let's move to a related topic. We're going to talk about reducing roots. Okay. So again, this is just me picking out some stuff. It's related, but I would just see where you're at. Do you know how to reduce the square root of 12?
No.
You've never seen this before?
No.
Okay, good. That's good. Now maybe you haven't just forgotten. Related question, do you remember the first prime number?
1.
1 is not prime. It's neither prime nor composite.
Oh, in that case, it would be 2.
Good. Do you know the next prime number?
3.
Good. How about the next one?
And then 5.
Okay. What's the next one after 7? What's the next one after 7?
11.
Good. We're going to stop there. That list also goes on forever. Have you heard of a factor ladder or a factor tree?
No.
Okay, so I'm going to use a tree. You might see a ladder. I don't know how they're teaching this sometimes. Is 12 divisible by 2?
Yes.
2 times what number gets you back to 12?
6.
6. And then you try 2 again.
3 times 2.
Right. Now, what you're looking for
It'd be 2 squared times 2 squared, right?
Yes.
Times 3.
That's right. So what you just told me here is correct. What you gave me is that square root of 12 is 2 squared times 3. Now, the
Mhm.
way you reduce these after you've seen them for a while is you realize that when there's a pair, the pair comes out.
Mhm.
So the 2 is going to come out, and the number that's
Mhm.
left over on the leaf stays in. So
Mhm.
your answer always has something on the outside and something on the inside.
Oh,
So in your problem, there's a 2 on the outside and a 3 on the inside.
okay.
Does that make sense?
Yeah, it does.
Okay. So if you understood that, I think you did. Try this one for me, please.
20. Okay. So first I would do it 2 to 10, and then 10 to 5 to 2, and then it would be 2 squared on the outside and then 5 on the inside.
So let's go back and look at my answer. Was there a squared on the outside?
No. Oh, okay. So just do
So
2 on the outside and then 5.
so the pair is consumed into one. Like you have
Oh, okay.
two twos, but you only bring one out. And I can give you more explanation on that, but that was really good. So 2 and 10, 2 and 5. So
Mhm.
the leaves generally have prime numbers on them, or you should get it down to all prime numbers. And then you just circle pairs as you go. Okay.
Okay.
All right. So now,
Mhm.
you might think, oh, I've got this down. What if I gave you something like this, the square root of 45? Now you try 2. You always try 2, but 2 doesn't work here because it's an odd number.
Mhm.
So you move to your next prime number, which is 3.
3.
Do you know if 3 works in this?
Um, I think it.
So here's the divisibility rule for 3.
Yeah, it'd be 15.
Yes, you add up the digits, and if it's a multiple of 3, you're good. And then you
Mhm.
try it again. Does 3 work in 15?
Yep, and then I do 5 times 3.
That's right. Now it's important to kind of keep the right ascending order here, where the smaller numbers are on the left leading to the larger numbers.
Okay.
So again, I like to
Okay.
circle pairs. So help me out here. What goes outside, what goes inside?
Uh, 3 on the outside, 5 on the inside.
Very good. Okay. So the idea here is that when you're looking for these pairs, they should sort of jump out at you. Okay.
Mhm.
Because you do this over and over again. Now, let's look at another problem here. Just go into one of my worksheets to find a good one for you here. So let's look at the square root of 60. Okay.
Mhm.
2 and 30, 2 and 15, 3 and 5. Okay.
Mhm.
There's just a pair of 2s.
So it'd be
So
2 on the outside and then
that's right.
3 times 5 on the inside.
So you don't leave it like that, though. You leave it as 2 square root 15 as your final answer.
Oh, okay.
Yeah. And that's important because you'll get some numbers on the outside. You also multiply them. Okay.
Oh, okay, I see.
All right. So here's one for you to try. I need to just step away from for 30 seconds, but I'll be right back. Go ahead and give that a try, and I'll check back with you in 30 seconds.
Okay. All right then. Mm.
How are you doing on this one?
I got it. So first I would do 5 times 27.
Okay, but does 3 go into it?
Oh,
The
yeah, it can.
the order really matters. Like you really want to do it in this order. Now you will still get the right answer, but sometimes you get the right answer for the wrong reason, and you don't want to do that in math specifically. So this is 3 and 45,
Mhm. It will
3
be
and 4.
5 times 9. Oh,
So you
15,
keep trying,
15.
you keep trying the number. You keep trying it until it doesn't work.
Oh, okay.
Like you're going to practice driving, and maybe, I don't know, you still have to do parallel parking when you're driving, or 3-point turns.
Mhm.
Do you know if you still have to do that? I'm not sure.
Um, yeah, you still have to.
Okay, so you keep trying something until it works, or when it works, you just do it over and over
Mhm.
again. Like if you're practicing for a test, you're like, all right, let me keep doing this problem. Same idea here. you keep trying the number
Mhm.
until it doesn't work anymore. Okay.
Oh, okay.
So like, and I'll give you another example next where that really emphasizes this, but you can see you circle the pairs, it's 3 square root 15.
Okay.
Okay. So here, new example, and this all relates back to triangles. We'll get to that shortly. Let's say I wanted you to find the square root of 32. So you try 2.
Mm-hmm.
And then does 2 work
16.
again?
Yes.
Yeah, so you keep
8.
trying it. 8, great. Does 2 work again? Yep, keep
And then
going.
4, and then 2 and 2.
There's a lot of 2s here, right? So you circle the pairs. For each pair, you can bring one out. Okay,
Oh, okay. So it'd be 2 times 2 on the outside. Wait, 4
right.
on the outside,
4 on the outside, root.
and then 2 on the inside.
Exactly. So the pairs, and the pairs can be the same number. They can be different. Let me see if I can find another one here for you to look at. Let's see here. Yeah, so I want you to try this one on your own, please. And please really try to go in that order. Try 2 until it doesn't work, then try 3 until it doesn't work, and so on.
Okay, got it. All right. So it'd be 72, then 2, which would give me 36, and 36, 2, 18, and then 18 by 2, which would give me 9, and then 9 would have to be 3 by 3.
That's right.
So it would end up being, let's see, 2. So that's 1 pair is a 2. And then that'd be just a lonely 2, I think.
That's right. So what goes,
And then, so it'd be 2 on the outside, and then 2 times 9 on the inside, which would equal 18.
okay, really close here. And you said all the right things, so I'm just going to work it out here. 9 breaks down into 3 and 3 though, doesn't it?
Oh yeah, so it'd have to be on the outside.
Yeah, and so
So
you
6
keep,
and then 2.
yes, 6 square root 2 on this one. Good. Okay, let's have you try. I don't want these to get too big. Just looking at my answer key here to make sure they're within reason for you. All right. Okay, here's another one for you to try on your own here. Square root of 96.
96, okay.
Yeah, so go ahead and give that a
So then
try.
I do 96, 2, so 48, and then 48 would be 24, and then
Yep.
24 would be 12, and then 12 would be 6, and then it would be 2 times 3. And then so that would leave me with 2 on the outside, 2 2s on the outside, which would be
Okay.
4,
Very good.
and then it'd be 6 on the inside.
Yes. Now here's how I check these, by the way, without doing the work. I square the 4 and I multiply it by the number under the root. So 4 squared is 16 times 6 is 96. Now let's go back and see if that works for all the other ones. Okay. Is 6 squared times 2 equal to 72?
Yes.
Okay. How about this one here? Is 4 squared times 2 equal to 32?
Yes.
Okay. I think you're seeing a pattern here. 3 squared is 9 times 15 is 135. Write that down. So that's your check. I mean, you sound like the type of math student that would appreciate that. This is 4 times 15 is 60. All right, so we got it down. Fantastic. So why did Matthew give you all these problems? That does
To help me master that topic.
Of course, but related to triangles, right? You might be thinking, well, why would I ever need that in triangles? Well, you're going to see that here, problem number 1. All right. So if A is 6, B is 4, solve for C. So it's always good to label them in the drawing. If you don't like the letters, you can come off to the side and relabel them. Okay. So we're going to use Pythagorean theorem, right? A squared plus B squared equals C squared. So that's 4 squared plus 6 squared equals C squared. That's 16 36.
16 plus 36 would give you 52.
Right, and now you'd have to take the square root of both sides.
And then you do that little, and then you do 2
Right.
to the, oh, okay.
So that's why we're learning that, because now you've got to be able to reduce the square root of 52. So I'll let you take it from here.
So then I do 52 divided by 2, which should give me 26, and then 20 divided by 2, 13. And 13 can't be divided by 2. 13 can't be divided by 3. Is 13 a prime number?
It is, yeah. So you can always go out to the internet and look for, a list of prime numbers, but yeah, so your answer, final answer, I think I heard is 2 square root 13.
Yeah.
And this is what your teacher expects. They don't want you to go to your calculator and say, well, it's about 7.1. They want this.
Oh, okay.
This is considered exact. Right. Are you generally allowed to use a calculator in your class or not?
Yes, you are.
Okay, well, I'm not anti-calculator, but this is how they are generally taught. So just keep that in mind. If your teacher says, hey, use a calculator, go with your teacher. They're the one grading you. I am not giving you a grade for today's lesson. So,
Okay.
all right. Sometimes the triangles are oriented differently.
But you just kind of got to just flip them.
If you want, you just have to remember that the two legs, which are near the 90, are A and B and C. And Pythagorean theorem still applies. So I'd like you to give this one a try. It's a little more difficult than the ones we've been doing, but I think you can do it. So if you have questions, please ask, but I'll just wait for you to give me an answer.
320, and then do 320 squared. Okay, so it'll be 320, right? And then I do 320 squared. So that would give me, hold on. That would be, well, it would leave me with a decimal. Oh, hold on. I need to do that differently. I need to do it.
Yes, we're reducing roots today. I mean, you can use a calculator in class tomorrow if that's okay.
So it would be,
I just want your final answer, whatever that is.
right? 8 on the outside. Hold on. And then hold up, I do 64 times.
That sounds good. Yeah.
Yep, I just checked it. It's 8.
What is your final answer?
8 on the outside, 5 on the inside.
Okay, so the way that we should learn how to say this properly: 8 square root 5.
8 square root 5. Okay.
Perfect. Okay, really good. No, that's fantastic that you're able to do that on your own. That was I would consider that an exam type question that you might see. So now the other situation is what happens if I give you the leg and the hypotenuse. So we kind of saw that earlier. Let me just snip in a new problem here for us to look at. And this will probably take us to the end of our lesson for today. All right, here we go. Okay, so if B is 6 and C is 8, solve for A. So again, I like to write the formula every time. It helps me to remember it. You will forget them if you don't write them now and use them. Notice that you're not given the leg this time. So it's A squared plus 6 squared equals 8 squared.
So I'd have to do 64 minus 36.
That's right.
28. And then I need to reduce 28, or
that's right. That's right. So go ahead and do that.
Of 28?
Yes, go ahead and reduce square to 28.
Okay, so then I do 28 divided by 2, 14 to 7. So it would be 4 square root 7.
Well, it is, you're close. You're really close. So 2, 14, 2 and 7, circle the pairs, 2 square root 7.
Mm-hmm.
So,
Oh,
so I
2
heard,
square
I heard,
root
I heard a 2 squared or something there. Okay, let's have you try one more here. Let's have you try 19 here. Sorry, you don't know what 19 is. This comes from one of the worksheets I have on my website, so I can direct you to that when we're all done here.
7.
But yeah, why don't you try this one? This will be our last problem for today, and we'll see
Okay,
if your
so
dad's
let's
around for some feedback.
see. So for you, all right then, 12 times 12, 144, 144 minus 16, 128, 128 divided by 2, divided by 2, 2, divided by 2, divided by 2. So that would leave me with 4 square root 8.
You can reduce 8. 8 goes down. So everything I heard was really good. A
Oh, no,
squared.
4 square root. Hold on, 4 square root. Yeah, 6 square root 2.
Really close. 2 and 64.
Mm-hmm.
2 and 32. 2 and 16. 2 and 8. 2 and 4. 2 and 2. Okay. And you start circling pairs.
Wow.
You sound like the kind of math student that works really fast, but maybe isn't showing enough work.
Okay.
Not sure, but you bring a 2 out for each of these.
Okay, so it'll be
And it's
8
2
square
times
root 2.
exactly. You have to remember to multiply 2, 8 squared 2. All right, really good. I hope this was interesting to you. If your dad is available, love to give him some feedback, talk to you guys about scheduling.